We are going to continue our discussion of solving systems of linear equations, but this will focus on algebraic methods. And the reason we want to have different methods is because sometimes it's very difficult to determine the solution to a system of linear equations using the method of graphing. Graphing is wonderful because it gives us a visual understanding of what we're actually trying to do. We're trying to see if two lines actually share a point, if they have a unique solution. But the problem is that graphing can limit the accuracy of actually identifying the point, because maybe the x and or y coordinates are integers. They could be fractions, they could be decimals, they could be difficult to actually identify. So instead, we want to turn to methods that are more precise. So this gives us our two algebraic methods that we're going to focus on: the substitution method and then what is called the addition method. So steps for solving a system of equations by using the substitution method. The first thing that we're going to do is isolate one of the variables. Now, it's not always going to be that you want to solve for y. We've gotten in that habit because of graphing, but maybe it's easier to solve for x. So keep your mind open. What is easiest to get by itself? We will then substitute the expression found in step 1 into the other equation. Now, the other equation is going to be very important because you're trying to combine these two equations. So you're really you're substituting one equation into the other. You will then be able to solve the resulting equation because you have gone from having two equations with two unknowns, also known as a 2x2, to now you're actually creating a 1x1, one equation with one variable, and that is not absolute value right there, 1x1. Once you find one of the variables, you will then substitute back to find the second one. And then we always want to make sure, is the point that I found actually the solution? So you're going to check it in each equation to make sure that it does work, and then write the solution as an ordered pair x comma y. So that is the method of substitution. And then we also have the addition method. So with the addition method, it is to your advantage to get each equation in standard form. So you want to get the x's in one position, the y's in one position, and then set equal to the constant. Optional step here is to clear your fractions or decimals for each equation just to make your life easier. Now, the addition method means I'm going to add vertically. So I'm going to add my x terms, I'm going to add my y terms, I'm going to add my constants in order for one of the variables to cancel. But sometimes, as they originally exist, they're not going to cancel. So that is why we might have to multiply one or both equations by a non-zero constant to create opposite coefficients for one of the variables so that a variable cancels. And then if a variable cancels, you then have a 1x1, which means one equation with one variable, and we can proceed as before, remembering we're going to substitute back, and we're going to check, and we're going to write the solution as an ordered pair xy. So let's dive right into our first example. So our first example, we're going to solve the system of equations using first the substitution method. So I want us to take a moment here. I want us to look at equation 1 and equation 2 and ask the question, what variable is easiest for me to solve for? Now, sometimes there's not an answer here, because maybe every term has a coefficient that's not 1, and so we're going to have to do some division in order to get x or y by itself. But do you notice equation 1? Y is almost by itself. We have just minus y. So I'm going to say 4x minus y equals 7, which means negative y equals negative 4x plus 7. We didn't do anything with the 7. But I don't want to solve for negative y, I want to solve for positive y. So that means we need to either divide through by a negative or multiply by a negative, or another way to say that is just to negate everything. So negative y becomes positive y. Negative 4x becomes positive 4x, and plus 7 becomes negative 7. Now, if you look back on your steps for using method of substitution, we're now going to take the resulting expression and substitute it into the other equation, because the other equation also has y, so I can substitute it in. So we have negative 2x plus 5y, but from the first equation, y is 4x minus 7. Now we have to finish representing our second equation, and in the second equation it was set equal to the constant 19, so we need to maintain that. Algebraically, do you see the next step that we need to do? Do you see that we need to distribute? So we have negative 2x plus 20x. Don't forget to fully distribute the 5 with the 7, but recognize it is going to be separated by subtraction. And now we can combine like terms. Now there are two things that we can actually combine. The negative 2x can combine with the 20x, giving us 18x. And we have a constant of 35 with subtraction in front of it, so we can add the 35 to the 19. Watch your arithmetic, which gives us positive 54. And then in order to solve for x, we need to divide by 18. And 54 divided by 18 gives us a positive 3. Now x is equal to 3, but remember we're trying to find the solution to the system. So we not only need x, we also need y. So the easiest way to solve for y is recognizing, well, I have y equals 4x minus 3. So y is equal to 4 times x, but we just found that x is 3, and then subtract 7. So y is equal to 12 minus 7, or y is equal to 5. And so the solution that we found is 3, 5. We're going to resolve this now using the addition method. So for example 1, notice this is the same equation 1, the same equation 2 that we were able to solve using the substitution method. So we're going to actually resolve this using the addition method. Notice both of these equations are written in standard form. We have the x terms first, the y terms, and then the constants. Notice the coefficient of the first x term is 4. The coefficient of the second x term for equation 2 is negative 2. If we simply add them, they will not cancel. That is the same for the y terms. If we simply add them, they will not cancel. So we need to figure out what we have to do to one or both of the equations in order for the variables to cancel. Now you have a couple choices. One choice that you can make, this is a choice, is you can leave the first equation alone. But in order to get rid of the x variable, I would have to multiply the second equation by 2. So notation for this, I'm going to leave the first equation alone. And then I'm going to take equation number 2 and I'm going to multiply it by 2 and then add them. So again, make a note of this in your notes if you need to. This notation means I'm taking equation 1, I'm leaving it alone. And then I'm going to add 2 times equation 2. Let's see why. I'm leaving equation 1 alone. And then I'm going to take 2 and multiply it through equation 2, giving me negative 4x plus 10y. And I need to multiply all the way through. 19 times 2 is 38. And then I'm going to add, remember we're going to do vertical addition. Do you see why we multiply equation 2 by 2? Do you see what's happening with our x terms? They cancel. So this gives us 0x. I'm not going to write that. The y terms do not cancel. We're going to see an example in class of what happens if the y's cancel also. Negative y plus 10y gives us 9y, and 7 plus 38 gives us 45, and dividing, we have y equals 5. And now I can back substitute. I can either, this is a choice, go to equation 1 or equation 2 to find x. I'm going to choose equation 1. This is just a choice. So 4x minus y, but we found y to be 5, is supposed to be 7. Solving for x, we're going to add 5, which gives us 12, and then divide by 4, which gives us 3, which gives us the same solution as what we had above, 3, 5. And I am going to take some time just for practice. I'm going to make sure we're okay here. What if I made a mistake with both my substitution method and addition method? So I'm just going to take a few moments. It does not take long at all, does it? So 12 minus 5 is 7. Finish your check always. 7 equals 7. That makes me feel good. And then negative 2 times 3 plus 5 times 5 is supposed to equal 19. Negative 6 plus 25 is indeed 19, which proves 3, 5 is our solution. So always do 2 checks, which leads us into our question. So for an ordered pair to be a solution of the system, it must satisfy both equations. If it fails in either equation, it is not a solution. That probably means I either graphed incorrectly or I made an arithmetic mistake. I forgot to multiply all the way through. I made an algebraic mistake. Something went wrong. So if it's not working in both equations, we made a mistake. So you are going to determine if the ordered pair 5, 1 is a solution to the system of equations. And remember, it is only a solution if it is a solution of both equations, equations 1 and equations 2. If it doesn't work for one, it is not a solution of the system. So see what you have there.